So, introducing our second speaker of today, Konstantin Solodovnikov. He is the CEO of Innolith, and with 25 years of international business experience and an MBA from the Chicago Booth School of Business, Konstantin brings valuable expertise. Innolith, a Swiss company, is transforming electric mobility through sustainable battery cell innovation. Their mission is to make electric mobility more affordable, powerful, and sustainable, paving the way for a greener transportation future. Thank you, Konstantin, for being here today, and over to you.
Thank you, Lovisa, for the invitation and for this introduction as well. Thank you for Swedish American Chamber for the invitation of our company. Certainly, it's a great opportunity for us to present what has been developed by the team in those 5 years that we're in business. I'll share my screen a second. Let me know if you can see the presentation.
Yes, we can see it. Thank you.
Very well. First of all, a few words about our company. We are a startup from Switzerland with operations in Germany and also a small office in China. Today, Innolith is 5 years old. We have 85 employees, of which majority in Germany, where we have an R&D facility and a large lab with our own battery cell manufacturing for prototyping, R&D development, and the final preparation of technologies to industrialization step. By this date, $100 million has been invested into this project, and in 5 years, we've developed a significant portfolio of IP, and in total, we have 400 patents, of which 80% granted and 20% pending. I will show some more information about this technology in the following few slides. Our major invention is electrolyte. Electrolyte as the conducting agent between cathode and anode, as you know, and today, majority of manufacturers use conventional lithium-ion technology, where electrolyte is dissolved with organic acids. And the organic acids, they're flammable, and they also have a limitation of voltage. So basically, the technology which is widely used today has a limitation, and this is the area where our startup is working on. We're trying to go beyond conventional lithium-ion to find a solution to produce battery cells that will be cheaper and that will perform better. We've made our major invention in 2019, the year after the company was established, and until now, we've developed a full cell product that is ready for commercial production. The major problem which we're addressing is price difference between electric vehicles and vehicles with combustion engine. Even today, after all the improvements in battery cell technologies, there is still 10 to 20% cost difference between ICE and EV. And the majority of this comes from battery cells. And our target from the very beginning was not just to develop a cell that would perform better, but also cost less compared to the conventional lithium-ion technologies. This technology that we've developed is not suitable only for electric vehicles or just for electric vehicles, e-mobility applications in general. And the 6 major challenges that we see for wider electrification and spread of electric vehicles and other forms of e-mobility are cost, again, and then high energy density of battery cells in order to store more energy, improved safety, also a very well-known parameter that unfortunately is currently an issue. Wide temperature range to make sure that a vehicle can be used in different temperatures, not only hot temperatures, but also low temperatures during those times when temperature is below 0. Improved recyclability, and here we are fully in line and have same opinion with the previous speaker. Recyclability of battery cells is not fully implemented. It's just the business which is studying in parallel with battery cell manufacturing, And here our technology offers advantages. Plus fast charge capability that is very important for consumers. We've developed our technology based on electrolyte, as I've mentioned, our major invention made in 2019. And the advantage of this electrolyte is that it's liquid and inorganic compared to organic electrolytes that are used today. Being inorganic and having outstanding conductivity, which you see in line 1, we have roughly 20% higher conductivity with higher voltage that we use. Our electrolyte is stable beyond 4.2 volts, what is a limit for conventional lithium-ion systems, up to 5 volts and even higher. We have a conductivity at room temperature, which is 4 times higher than for conventional lithium-ion systems. And with this conductivity, our electrolyte can stay liquid and still conduct electricity at low temperatures as low as -60. And on the high side, it is still stable up to 80 degrees Celsius for operational temperature. Electrolyte does not have flash point, which makes the system more stable and the risk of fire propagation significantly lower. Our electrolyte works with all the commercially known materials. Everything that is produced today at mass scale can work with our electrolyte. So in a way, it is the whole class of new technologies that can be developed using our electrolyte as a basis for new cell production. We have, as I've mentioned, a significant number of patents compared to some of the industry players which would be known to you, like QuantumScape or Prologium or SES. We have a comparable number of patents, 50% of which are in Europe, and then the rest are worldwide in every battery producing or end user country. We have in total 24 patent families, which is also really an advantage compared to some of other startup companies working on new technology development. The way it works is shown on this chart. You can see a standard charge and discharge curve, and even if you are not familiar with the physics or electrochemistry, it's very simple and shown on the chart. You can see that lower dash line starts at 4.2 volts, and it shows 100% of capacity in the battery cell that can be achieved by using conventional lithium-ion system. With our electrolyte, we can cycle the same cathode and anode materials to higher voltages, provided they stay stable at those high voltages. For example, NMC811, which is a widely used high nickel chemistry, is stable with our electrolyte up to 4.6 volts. And using 4.6 volts, we get access to 100% of lithium that is stored in the cathode material. So we are not creating new materials, we're improving efficiency of use of those materials that are already in the battery cell. And this 20% of lithium is normally not accessible with organic solvents, and it is basically dead weight in the battery cell that then results in higher cost and lower efficiency in operation of a battery cell. By cycling system with NMC811 to 4.6 volts, we get extra 20-25% of capacity, and with higher voltage that we can use with electrolyte, we can also develop a wide range of applications. And in order to lower cost of battery cells and make their performance better and also more suitable to the needs of customers, there can be two possible ways how we can do it. Using or utilizing capacity of cathode material 20% higher than in the conventional electrolyte. We produce cells with higher energy density, and then having possibility and to cycle our electrolyte to high voltages, we can develop additional systems where as cathode materials we can use manganese, which is abundant in the nature, and this manganese can be used to replace nickel, cobalt, which are first of all expensive, and then also they are not widely available in nature. And with the use of manganese, higher voltage would be applied, cost of cathode material will be less, and performance trade-off is significantly smaller than cost advantage and performance advantage which we can achieve using our electrolyte. Compared to solid state, which is widely expected to solve some of the same problems, we have much faster path to the market. The technology is fully ready. We can produce it using standard equipment and standard materials, and cost-wise, it's incomparable to solid state. We have a significant advantage here. To illustrate why we believe that in terms of manufacturability, we would have an advantage, you can see on this slide that we can produce our technology, which is in the middle, compared to conventional lithium-ion exactly in the same equipment, using supply chains and materials which are used today by the industry. So switching cost would be minimum, plus our technology can work with silicon. We have ongoing development of new technologies with silicon for higher charge and discharge, but unfortunately it comes with a trade-off of cycle life most of the time. And again, compared to solid state, in terms of manufacturability, this technology is much better because there is no need to retool production sites. Basically, a battery manufacturer that wants to use our tech can buy equipment off shelf from one of the existing equipment suppliers, and then with the mass-produced materials, start manufacturing this technology promptly. In the future, and this is lower part of this table, we are also working on lithium metal concept, where in the standard cylindrical cell, we use lithium metal to produce battery cells with higher energy density than any conventional lithium-ion cell can achieve today. All in all, compared to conventional lithium-ion, our technology has three major advantages when it comes to the cost. Number one has been mentioned: high utilization of cathode capacity allows us to use either less metal inside of the cell and then achieve the same capacity, or we can still use the same cathode material, the same quantity of cathode material, and we would increase energy density. That eventually reduces cost per kilowatt hour of all of the materials in the battery cell. Plus, our technology has advantages in the production process, and probably I will spare the details here, but efficiency of producing our technology in the real industrial environment is significantly higher because it requires less conditioning of the environment, less cleaning of air and water. Speaking about ESG, it's very clear that when one uses less metals in the battery cell, CO2 footprint will be reduced. That is a big contribution to make battery manufacturing and electrification even more ecologically friendly than it is today. And additional, and it's certainly not the least, our electrolyte can be recycled. Conventional or organic electrolytes, which are used in every battery cell today, cannot be recycled. Unfortunately, salts which are used with the solvents, they are lost during recycling process, and that is 7 to 10% of total weight of battery cell. So in the future, when in Europe and in other countries, step by step, there will be significant requirements of recycling higher percentages of used materials. Our advantage of having electrolyte that is recyclable will play an important role in an advantage to our technology. What I haven't mentioned, our solvent is a waste material of energy industry, fossil fuel industry. We're using waste material of oil, gas exploration, coal, metal smelters, and this waste material is used as a solvent for battery cell production. And with all the advantages that I've described, this is really an interesting part where we're taking waste from fossil fuels in order to reduce their use and proliferate electrification. That is our first technology, which is currently ready for mass production. And we are in discussion with several partners in order to start licensing our technology using their available battery cell capacities. Our cell has less cathode material inside and lower cost. It has 300 watt-hours per kilogram energy density, which is fully available. There is no reduction in order to extend battery cell life. Its energy is fully accessible in and out. We have higher safety. Our electrolyte is non-flammable, as I've mentioned in the beginning. In case of thermal runaway or production fault or overcharge of the battery, any negative event that can happen to a battery cell, there would be less energy release, 40 to 50% compared to the existing technologies, which reduces risk of fire propagation. And those ugly videos that all of us saw in the web, they wouldn't happen in case a car or other e-mobility vehicle uses our battery cells. Plus, on the temperature side, we can charge and discharge our batteries at the very low temperatures, -20 for charging, -40 for discharging, and more than 80% of energy is accessible at that moment. So in the morning, someone who uses an electric vehicle wouldn't need to heat up the battery first before starting. And the cold crank possibility with our battery cell is fully accessible. There will be no loss of energy, even if the battery is nearly discharged. Recyclability has been mentioned. In terms of C-rate capability or speed of charge and discharge, we're continuously improving this parameter, and today our batteries can be charged in 10 minutes, not even 15 minutes as before, and discharged at the same time. Compared to other cells in the market, we can show this chart. That's a group of battery cells on the left side with high energy density, and on the right side, battery cells with high power capability. In both cases, technology that we've developed is higher in terms of energy that we store in a single cell, and it has the same, even better power capabilities than the rest of the lithium-ion cells which are produced and commercially sold today. That's not the end. This technology is only the beginning of our journey. We're planning to develop new battery cell technologies in the coming years. And this dashed line here on the chart shows maximum theoretical capacity that is achievable with organic solvents and conventional lithium-ion systems. Beyond that, there is a need to find a solution. Solid-state companies are working in this direction. Some companies are trying to improve performance of conventional lithium-ion using silicon. In our case, use of electrolyte opens full paths to development of a wide range of technologies. You can see it on this chart. We're starting in the bottom left corner with NMC and graphite as a starting point, where our cell already has 300 watt-hours per kilogram energy density today, moving upwards to 310 and 320 still this year. And then we have really a busy roadmap where, depending on the partners with whom we are negotiating right now, we're using current cell technology as a proof of concept and really confirmation of possibility of our technology to deliver both on cost and performance. We have a possibility to develop new chemistries, either using manganese-containing materials or even sodium as a cathode material, and the lithium metal that would come to the market at a later stage. All of the chemistries that we are developing, they're suitable for e-mobility. First of all, that's our major market where we're planning to use our tech in the future. Plus, they can be used in battery energy storage, in aerospace, EV tolls, and urban air mobility. We've introduced our technology to marine and industrial applications as well. Today, we're using 21700 format. This is the same cylinder where Tesla started 10 years ago and currently uses it still in some of their car models. And 21700 is now replaced with a larger diameter cell, 4680, 4690, and this is what we're developing as well in our lab. These are live pictures from our lab in Germany and our colleagues producing battery cells, which are UN certified and can be shipped internationally to potential customers and business partners. We also have joint cell development projects with large auto OEMs as our partners, and we've introduced our technology to battery cell manufacturers and negotiating potential licensing deals. That would be our goal at the next stage. Now, when technology is ready for mass production, we are planning to work with battery manufacturers and those auto OEMs that they have plans to have their own cell production and license our technology. And at a later stage in the future, we will also build our own production and manufacture battery cells for several applications. This is not a modest one, but it is true in terms of having a distinguishedly different battery cell technology fully developed and ready for mass production. We are today the only company in Europe, and again, thanks to the Swedish-American Chamber for the invitation today and for the opportunity to present our company and technology. We are looking forward to commercialize this technology, bring it to the market to the benefit of all the consumers, which is our vision: e-mobility freedom for all. Thank you.
All right, thank you very much for that. It was very interesting getting to listen to you, and we really appreciate you being here. Your work with building better batteries is really impressive. And to the audience, feel free to ask some questions in the chat or the Q&A. There is still some time. Or if you want to wait until later, that is fine too. Let's see. So a few questions. You mentioned earlier that there are some barriers that you have to overcome. And the question is, which has been the hardest barrier to overcome or to beat in order to innovate your batteries?
The hardest barrier came at a later stage when we started introduction of our technology in the market. Several teams worldwide tried to make research in the same field which we are working on, and unfortunately they failed, or fortunately we succeeded. So there is a strong perception that inorganic electrolytes, liquid electrolytes, normally should not work. So we have to convince people that despite of the fact that others failed, the technology and solution exists, and it works, and it can bring lithium-ion world in general to a better stage of performance and lower cost. And it takes quite some effort to convince people, and that's why we had to produce full cell battery cells ourselves. We could not just give electrolyte to a company and ask them to make experiments. They normally wouldn't believe. The battery world is full of different stories and claims and speculations that people make on a weekly basis. So unless someone can really touch a cell, test it, and validate technology, usually consumers or end users, they are very skeptical. So it took us a while before we started getting significant traction in the world. And today we have really unbelievable partners, and we're very happy that the effort paid off.
All right, thank you very much. And there's another question here. Great innovation. It seems like a no-brainer. And what is blocking your technology from all to adopt it?
There is no block. If we had more resources, perhaps we could have moved faster. That is maybe a very standard limitation for a startup company. You need to do a lot of things simultaneously, and I believe other speakers will agree with me. You need to work with the customers. You have to have your product ready, and you need to produce at some point of time, and you cannot do all these things simultaneously efficiently if there are some limitations of resources. Now looking back, I wish we started a bit faster and moved to the market sooner. but it's not too late. Knowing that conventional lithium-ion technologies have a limit, and having proof in our hands that we know how to overcome these limitations, we are currently trying to raise capital, and it's going well. And I'm looking forward to scale up our technology and produce sooner than later.
Right. Thank you so much for that. And thank you all for the questions.